Yes, thank you. So greetings to all, wherever you are. Thank you very much for your presence. So my name is Ana Luísa Garcia-Oliveira, and I'm the Regional Genotyping Coordinator for the Breeding Resources at the CGR CIMMYT, and I'm located in Nairobi, Kenya. So Natalia, first of all, Natalia, Zerka, and myself, we want to express our gratitude for this opportunity that, like Laura said, it came from the attendance of the Speaking Science third edition online training given by the VIB-IPBO, and to talk about the topic entitled Advancing Crop Potential, Enhancing Food Security and Nutrition Through Phenotyping. So from this seminar with two presentations, we can expect to gain some holistic understanding of the interconnected state elements that uncover the transformative power of phenotyping in building more resilient and nourished future. So from this seminar with two presentations, we can expect very briefly to be structured with two participant pools at the very beginning and at the end of the webinar. So you can give your opinion about it and give some ideas, followed by a brief introduction to phenotyping in Africa to introduce the topic, followed by the presentation of Dr. Natalia Palacios and Dr. Zerka Rashid and respective questions to address. And finally, we will open for questions to every participant of this webinar. So please stay with us until the end if you can. So the first, we will see the opinion pool. How can phenotyping contribute to enhance food security and nutrition in regions like Latin America, Africa, and Asia? So let's see if the pool comes. Just a moment, please. So I hope you are able to see the pool, and let us give 1 minute to answer what you think. How can genotype contribute to enhance food security and nutrition in regions like Latin America, India, and Africa? Either by identifying crop varieties that are more resilient, by improving the nutritional content of crops to address specific dietary deficiencies, by increasing crop yields through the development of high-yielding varieties, or all of the above. So we still have a few seconds to participate, but by now, majority of the participants think that is all of the above. So I think we can share already the results. Later on, you also can put what you think in the chat. And I hope you are able to see the results. So majority of the people think that is all the above. So starting by the importance of the phenotyping. So phenotyping is very important because firstly, many advances were made in the genomic approaches, but these need to be complemented with accurate field phenotyping methods to have reliable results. Also, majority of important agricultural traits are complex and they are quantitative in nature. So they really need reliable methods, and this includes the phenotyping. Additionally, precision agriculture remains a cardinal principle of the field phenotyping. So using sensors, but also drones and other technologies like AI, the precision agriculture will allow us to make better use of the resources, like, for example, pesticides, fertilizers, but also water. But also will allow the farmers and researchers to improve the crop production and also reduce the environmental impact. So taking this in consideration, phenotyping in Africa, very briefly. So it is done traditional phenotyping based on manual methods, and these are time consuming, it is laborious and costly. But if we want to increase the genetic gains and also have effective selection in the breeding programs, reduce the costs, and have more efficient monitoring of plants, we need to advance the plant phenotyping. And in this, the CGIAR and partners are in partnership with all the institutes over the world. They are doing great progress. And I just put here an image. I will not explain it, but I give the sources. And in 2023, Kojoy and colleagues, they publish a very good paper where they give examples of what is being done together with the CGIAR in the phenotyping in Africa, either in Kenya, Zimbabwe, and Zambia. And we can see here that we also have facilities in Africa that can progress the phenotyping, like, for example, in the University of Mohammed VI in Morocco, but also here in Kenya in CIMMYT, where we have phenotyping facilities that can be used and explored. So because as we advance in the phenotyping, I will present Dr. Natalia Palacios Rojas, that she will present the phenotyping grain quality. So Natalia, she's a microbiologist from Colombia, and she did her PhD in the University of East Anglia and the John Innes Center in the UK. So Natalia has a lot of experience in the public and private sectors, and since 2005, she has been the quality specialist at CIMMYT Mexico. Natalia's primary focus lies in bridging the gap between the field and nutrition. And finally, she played a crucial role in developing maize germplasm with high nutritional quality. So thank you very much, Natalia. Please go ahead with your presentation. I will stop sharing.
Okay, let me just share the presentation. Just a second.
Natalia,
Yeah. Now I cannot see my screen. Let me see. No, this is not the one. I don't know why it's not coming.
If you prefer, I can reshare mine.
Just a second. Give me 2 seconds, and because I made some changes in the. Okay, now it is here. Perfect. Oh. Okay, now you can see my screen.
Yes, thank you.
Perfect. So good morning, everyone, and thanks for being here. Well, I guess we all enjoy having a nice piece of bread or a taco or perhaps chapati or a full meal with a lot of different components, vegetables, legumes, and of course, it's very nice to have a bowl of rice to be with it, you know? And also for people, they really enjoy having a very nice plate pasta. So it's not that I am hungry, it's actually that is part of our diet and our culture, that we enjoy having a very nice food. And we actually enjoy having a very good quality of the food, because for instance, if we have a pasta which is very hard, we don't enjoy it. Or when we have rice, for instance, we really like to have a very smelly and very flavory rice, and it happens the same for all type of food, not only when we talk about cereals, but also when we talk about fruits or vegetables or legumes. So that's why it's very important that we develop varieties, or we use varieties that are already available in nature, and that have good quality for the processing or to eat them straightforward. We don't enjoy a very hard strawberry or fruit. We want it to be sweet, soft, and that we enjoy. So when we talk about the agriculture system and actually the food systems that allowed us to have access to our daily food, at the beginning, we were ensuring the food security. So just having enough food to eat. Then we realized, okay, it might be important actually to combine nutrition and security, so having enough food, but recognizing the hidden hunger that was a big problem worldwide, meaning that we were lacking essential micronutrients that we were not consuming in our diet in enough quantities. But then we are all aware that we are reaching the planetary boundaries and the health boundaries of the health system. That meaning that we are taking too much of the resources of nature, and actually we have become big problems in terms of health, not only micronutrient deficiency, but also some nutrition problems like obesity and overweight. So we have to think of developing sustainable diets that are good for the environment. And now we have, because of the health issues that we are facing, we really have to think about developing smart food. So that is good for the consumer, is good for the planet, and is also good for the farmer, because we have to recognize that the farmers actually have been suffered a lot from the current food system that we have. They are the ones that are working really hard and actually are not having the great benefit of it. Okay, so now. Okay, so when we want to contribute to the development of that smart food, grain quality specifically, and of course it applies to the quality of any kind of food, vegetable, fruit, legumes, is really important. Why? Because if we ensure that the rice, wheat, maize, sorghum, millet, whatever cereal that we are developing has the nutritional quality that people requires, so it will contribute to have a nutritious food in the plate. Also, it will help to improve the marketability of the grain that the farmers are producing, because it's not the same to develop a grain that people cannot transform, or that people have to invest a lot of energy, a lot of resources in order to have it good, to be able to eat it and enjoy it. Also, when we talk about grain quality, it also involves the safety of the grain. So the sanitary conditions of the grain, meaning that it is not contaminated with fungi or certain bacteria, or it is not actually contaminated with mycotoxins that are being produced by the fungi. And if the production is clean, so all production can be used and can be consumed. But if it is contaminated, if it is damaged, then we are going to waste a lot of grain, and the production will be not sustainable. So if we ensure the safety and the sanitary condition of the grain, we ensure sustainable farming practices. And we also contribute to the improvement of the farmers' livelihoods, because they can consume and or sell all the production that they are having. So in that sense, at the end of the day, we are contributing to food security, we are contributing to the nutritional value of the grains that are being produced and the economic bioavailability. So it is a great contribution to food demands, improve the health outcomes of the population, improve the food safety and the sustainability of agriculture. It's not moving very easily. Okay, so when we talk about grain quality and actually the phenotyping of grain quality, what are we referring to? We are referring to the physical, the chemical, and the safety attributes that impact the final use of grain. So if I can use it to prepare pasta or to prepare bread or cookies, or if I am talking about rice, if I am talking about a very aromatic rice or very sticky rice, depending on the application or the use that I will give it to it. But grain quality can be very subjective. So I can say this grain is hard, this grain is big, this grain is soft, or it can be actually very objective if I use certain methodologies in order to characterize those attributes. So instead of just giving the appreciation, I can have measurements, specific measurements to determine the grain quality. So in the case of grains, we are talking about physical traits like size, shape, color, hardness, etc., or chemical composition that actually contribute to those physical characteristics. So when we talk about chemical composition, we include moisture content, protein, starch, oil, micronutrients like iron, zinc, calcium, etc., fiber, digestibility properties, etc. And as mentioned before, safety factors are very important. How clean is the production? How clean are the grains that we are producing? And we monitor the presence of pests, certain contaminants, and also the presence of mycotoxins that, as mentioned before, are toxins that are being produced by certain fungi that sometimes colonize the grains. So why it is important, the grain quality? Well, because it affects the processing, the transformation capacity of the grain. So it will affect the milling of the grains, how much flour I can obtain from the grains, and also how much time or energy I have to invest to make those cereals easy to eat and to enjoy. So it will affect the cooking properties. So it's not the same, again, to have a wheat that has the characteristics to make a bread compared to a wheat that has the characteristics to make pasta or to make a cooking. In the case of maize, for instance, people say, well, I can use any maize to produce any type of food. But depending actually on the culture and depending on the food range that we have, that is not true, because I cannot use a popcorn type of maize, for instance, which is very small, very hard, to make a nice ugali, because actually I will have to invest a lot of grains in order to have enough flour to prepare the ugali. And perhaps the ugali at the beginning will be very nice, very soft, but if I leave it for a while, it will become very hard because it will absorb a lot of, it will lose a lot of water. So that's why the grain quality will affect the cooking properties. It's the same, for instance, let's talk about beans. I can cook any type of beans, but if it's very hard, perhaps I have to invest more time, more energy, more gas in order to make it softer and palatable for me and for my kids and for my family and for all the people. So that's why how grain quality will affect the cooking characteristics. Also, it will affect the sensory, just thinking about beans, for instance, or characteristics of bread being prepared with the wrong type of wheat varieties, etc. And it will affect also the nutritional characteristics, because not all cereals will have the same content of protein, oil, starch, and micronutrients. And as mentioned before, grain safety is very important. So if we just look at this image of maize and wheat kernels, we know that the kernels are actually composed by different structures, being the most important one, the pericarp or the bran, which is the outer part of the kernels. And that part is very important and really rich in terms of dietary fiber, protein, anthocyanins and other pigments, phenolic compounds, vitamins, minerals, and phytates. If we go deeper into the kernels, then we will see that we will have the main part of the kernels, that is the endosperm. And this part is rich in starch, proteins, dietary fiber, including resistant starch. In terms of the yellow maize, for instance, the carotenoids, that are the components that are giving that color, is they are accumulated in the endosperm, and also the endosperms have vitamins. And the next big component of the kernels is the germ, which is very rich in lipids. It also contains proteins, minerals, antioxidants, and vitamins, especially vitamin E. So the range of composition of each type of cereal will change according, of course, of the what species are we talking about, but also the variety itself. Let's say we are talking about maize, and you have to understand me that I'm talking a lot about maize because is the crop where I work more. But so let's think about maize. There are different varieties. There are actually varieties of different colors, different texture, different size. So the genetic is an important component that will determine the grain quality. But it is not only the variety, but also the agronomy. Because what happens if I grow my maize in a very poor soil, where it doesn't have access to nutrients like nitrogen? You know, nitrogen is the main component to make the proteins. You know, is the building part to form the proteins. So if the plant doesn't have access to nitrogen, then it will not accumulate, it will not be able to accumulate enough protein in the kernels. So agronomy is also a very important component, and is the interaction between the variety and the agronomy that will also affect the quality of the kernels. But we can make a very good job in producing, using a good variety, using a appropriate agronomic condition. But if when we harvest the kernels, they are not properly stored, then we can start having a compromise on the quality, especially on the safety of the grain. Why? Because when we harvest the kernels from the field, it comes with some natural fungi that are present there, and they take the advantage of bad storage conditions like high humidity or high temperature, and they start growing in the kernels. And on one sense, they will damage the kernel like that, or they will start also producing mycotoxins. And some of the mycotoxins are very dangerous for the human and animal health, and also will have impact in the, they can also affect in such a way that can cause the death of the consumers. So all these characteristics, all these factors, genetic, agronomy, and storage, are actually going to impact the safety and the end-use quality of the kernels. So how do we monitor or phenotype the kernels? So just to give some examples, we move from very basic methodologies. We use very basic methodologies, and we also use a high throughput technologies in order to do this phenotyping more efficient. But as I said, basic methodology like just for density, for instance, to determine the density of the kernels, we use what we call flotation index, and it's just putting the kernels in a solution with a specific density, and we just wait until the kernels float in that solution according to its density. So those kernels that are very hard, they will go immediately to the bottom of the solution. If the kernels are of intermediate hardness, we will have a separation of the kernels between the top and the bottom. And if they are very soft, they all will float. It's a very simple technology, very cheap. It can be done in the field, in the lab, in the house, in the processing setup, etc. And it will give us some information about how hard is the kernel. And also with that information, I can actually infer some cooking and processing methods in order to apply the right one. From that simple methodology, we can also use other methodologies, and without entering into details, just mentioning that we can have access to methods that help us to understand the rheological properties of the kernels. That is actually how the kernel is absorbing water, how the starch and that water is modifying the starch that is present in the kernels, and give some characteristics for the final product. So this is a RBA technology or a DSS technology. But we are also using images that these days are very powerful and very fast methodologies in order, for instance, just to determine the shape of the kernels, the size of the kernels, and in some cases also the hardness of the kernels, given by the difference in the absorbance in the image. We use also other technologies that allow us to move to analyze more samples in less time, and also being more efficient in terms of resources. And like that, we can talk about near-infrared spectroscopy, for instance, that for some small grains, we can actually analyze the kernels directly without milling, without destroying the kernels. In the case of maize, we do have to grind it because the morphology of the maize itself. Other technologies like X-ray fluorescence, ICP, or high liquid HPLC. Some of these technologies are time-consuming, are expensive, and some others are really contributing to the throughput of the analysis. Also, these days, we are talking about foodomics that help us to characterize all the food in terms of the bioactive compounds, help to food traceability, safety, and quality. And we are using different technologies like transcriptomes, proteomics, and metabolomics. And it is also the era of artificial intelligence and data management, data analysis. And I have to tell you that spectra and machine learning are contributing a lot. And we are taking advantage of all the data that we have generated through years and using machine learning to develop proxies that allowed us to predict much quicker and cheaper the characteristics of the kernels. So just some examples for cooking and eating quality. For instance, we look for the cooking time. There are different measurements like kernel hardness, cooking time, and different methodologies that we can apply. And also, for instance, for milling quality, so what we are looking for is the milling extraction rate, and some measurements that help us to determine that are the specific weight, the kernel hardness, the kernel type, and as mentioned, there are different methods like density, scanning, or just the separation of the different structure. And we see the ratio between the different type of endosperm in the case of maize, endosperm, hard endosperm, soft endosperm, and then we can have an approximation of the, contribute to estimate the milling extraction rate. Nutritional quality, there are different nutrients that we can determine using wet chemistry methods that normally are time consuming and perhaps a little bit more expensive compared to fast technologies, high throughput technologies like NIR or XRF. And for sensory quality, also the texture profile is very important, and also rancidity test in order to determine how stable is the flour when we store it for a long time. So just to give an example how we integrate this type of phenotyping in a breeding scheme when we are developing, for instance, high carotenoids, high provitamin A maize. So maize that has higher content of beta-carotene and beta-cryptosantine, which are carotenoids that have good properties for the health of the consumers. So when the breeders are developing these varieties, we are monitoring the content of these carotenoids. At the beginning, because, in the breeding process is like the funnel. At the beginning, they have so many varieties, and it's impossible to use HPLC because it's going to be more really expensive and time consuming. So we use NIR. And towards the end of the breeding process, we are checking the real values of the provitamin A carotenoids using a technology like HPLC or UPLC, just using liquid chromatography. But it is not, this phenotyping is not only being used for the breeding process itself, but it has helped us to understand and characterize the genetic diversity, and also to support the development of other tools that will improve the breeding itself. So for instance, we have having all the phenotypic characteristics, values for carotenoids, for instance, we managed to develop some molecular markers that now breeders are using in the early stages of the breeding process for provitamin A maize in order to accelerate the process and select faster the material that will have the characteristics. Of course, at the end of the process, we always have to do the phenotyping, but we can contribute to the development of molecular tools to enhance the breeding process. And like that, we can also contribute to the reduction cost of the breeding process. So it's not only reduction in time, but also reduction in cost and making much more efficient. So like that, I just want to finish my presentation, and I will be very happy to answer your questions at the end of the webinar. Thank you very much. Just for closing, if you haven't understand anything of what I have said through the presentation, just keep in mind that the quality phenotyping is the bridge between agriculture, between production, and our diet and nutrition. Thank you. Over to you, Zerka.
Thank you.
Yeah.
Thank you, Natalia. Thank you very much for the great presentation. So we decided to change because due to the time, because it's already 2:40, and instead of we ask now the question to Natalia, I will ask the question at the end of the seminar. So now we will have Zerka. So Dr. Zerka Mir, she's a microbiologist from the Central University in New Delhi, India, and with more than a decade of experience, she's working as a maize pathologist at CIMMYT India, Hyderabad, with a mandate on improving resistance to key biotic stresses. So she developed precision phenotyping sites at different locations in India for important diseases and working on protocols for artificial inoculation for disease screening. She is leading the disease diagnosis and identification of new pathogens attacking the maize crop in the Asian region. So, Zerka, please go ahead with your presentation in enhancing food security through disease phenotyping. Thank you.
Thank you, Anna, for the nice introduction, and thanks, Natalia, for sharing the screen for me. So, firstly, I'll give the introduction. We know that the global food requirement is projected to double by 2050 due to population as well as the socioeconomic growth. Meeting this demand is not easy, particularly in the developing countries. They need to double the current grain production, especially for the crops like maize, wheat, and rice. Therefore, maize plays a very crucial role in ensuring the food and the nutritional security, and also the livelihood of millions of the resource poor farmers. As the maize is mainly a food and the industrial used as a food, feed, and the industrial products in high economic countries. However, it also provides food, feed, and the nutritional security in the world's poorest regions of sub-Saharan Africa, Asia, and Latin America. And talking about the tropics, maize is predominantly grown under the rainfed conditions by the farmers. So there is often a threat of devastating diseases and pests that occur. Next slide. So it has been observed, Natalia, can you just go back? So 73% of the total maize in Asian tropics is grown under the stress vulnerable environment. Next. So the climate change. Climate change is having an impact on the maize diseases. We say that because of the climate change, there is the change in the environment. And that environment is having the potential to shift the pathogen dynamics in different agroecologies. Thus, the stress-related diseases that includes the stalk rots and the ear rots are predicted to have a significant impact on maize under these conditions. Therefore, what we have to do is that linking the agronomic practices of breeding for the abiotic stress tolerance like a drought and heat, and also breed for the resistance, and that will ensure the yield stability and the climate resilience. Next. Next, Natalia. So, emerging of the new threats to maize. So, as we can see that every time some new diseases are coming up, which we have seen in Kenya in the year 2011, where the maize lethal necrosis has happened. It is a viral disease that is caused by the two pathogens. So with that, it was firstly observed in the Kenya, but it has spread to the whole African countries and called the total yield loss. Similarly, next slide. Similarly, what we have observed, the tar spot complex, which is foliar diseases and mostly observed in the Latin American countries, and is also called by the multiple pathogens. Now we can see this. We can see this these pathogens present in the United States, which were not earlier present there. Next. Similar stories with the Asia. In Bangladesh in the year 2020 and the 21, they observed that their fully grown plants are showing wilting. And at the later stages of the development, and they couldn't guess what is it. And in the year 2022 and 23, again, it has observed in the southern district of Bangladesh, where they observed the root drying, rotting, and the drying of the whole plants. So they actually don't know right now what is it, but mostly it is the post-flowering stalk rot, which was not the disease earlier there. Next one. So coming to the foliar diseases which we are working in Asia are the Turcicum leaf blight, Mavis leaf blight, common rust, Polypsora rust, sorghum downy mildew, gray leaf spot, and curvularia leaf spot. Next. And the major soil-borne diseases of the maize in Asia are the stalk rots, which is caused by the charcoal rot, fusarium rot, and then there is a bacterial rot and banded leaf and sheath blight. Now, firstly, we have to understand that how this disease is occurring. So in that case, the disease happens when there is a favorable conditions. It's a disease triangle. We are having a susceptible host, we are having a virulent pathogen or the pathogen present there in a certain amount, and then there is a favorable environmental conditions that is creating the plants become sick. So now we can just prevent them by the regulatory approaches, genetic control, cultural control, which will prevent the conducive environment for the pathogens to grow, biological controls, and the chemical control. Next. So the global surveillance system can also be used in managing the diseases, which is a network of the diagnostic or the regional hubs sharing the disease and the pest related data with the integrated data management, risk management, capacity building, and the communication. Next. So in the integrated disease and pest management, we can have a surveillance, early detection, forewarning, and then agroecological and the social inclusiveness of the equitable management, biological and biopesticides, host plant resistance, clean seed systems, and good agriculture practices, and the quarantine and the phytosanitary regulations. These are the methods by which we can prevent the disease. So now coming to the precision phenotyping, which we are doing here is for the post-flowering stalk rots, that is the charcoal rot and the fusarium stalk rot, persicum leaf blight, banded leaf blight, and the ear rots. We are evaluating our germplasm, both inbred lines as well as the hybrid lines, and whatever is the resistance, we are taking them forward. Next. So now understanding that why we are doing, what is the ultimate purpose of the precision phenotyping? It is to identify the genotypic variability present in your germplasm. Second, enhance the precision and the efficiency of the data collection on the key traits along with the grain yield, and to estimate and factor the genotype into environment in the selection process. Minimize the experimental error by improving the trait heritability. Measure the heritable traits genetically and correlated with the yield and improve genetic gains. The last but not the least, it is to dissect the complex traits into the components of the genomic regions for the discovery, validation, and the use in the forward breeding. Now, if we talk about the breeding, we are having the conventional breeding and the molecular breeding, but the phenotyping is important in both, whether we will take the conventional breeding as well as molecular. We are having a diverse set of a germplasm, we phenotype it and feed it into our breeding program. Next, Natalia. And while in case of genotyping, sorry, we take this exact germplasm, we genotype it, then phenotype it, and then select whatever the promising alleles are there and fit in our breeding program. So what are the important factors that we have to keep in mind while doing the screening or while selecting the site for phenotyping? First is the soil type. It should be medium textured soil. It should not be too light. It should not be too heavy. It should be medium. It should be well-leveled field. It should not be uneven. The leveling should be very good. There should be a good drainage or the irrigation facility. So the cropping history, we have to avoid the cereal and the cereal cropping. So there should be a proper crop rotation. Planting time. Planting time should be as per recommendation of that area. Next. Good crop management. And then on station preferably, that so that the scientists can have easily access, see, the persons can easily go and check their trials. Another important factor for the precision phenotyping is the appropriate field designs and the statistical analysis, providing the optimal conditions for the disease development. So it is like we have to put the misting facilities so that the congenial conditions for the pathogen growth should be there. So we have to provide those, and the pathogen should be virulent, and then there should be optimal disease recording methodologies at the optimal stages. So we have to specifically see, okay, fine, we have done the inoculation. After how many days we have to take the first scoring? And after that, how many times we have to take the final scoring, so that those things should have been optimized before starting of your experiment. Next. So what we are doing is we are doing the phenotyping for the sorghum downy mildew. In that case, what we are doing is planting the spreader rows after every 10 after the planting of every 10 entries, that there is a 1 or 2 spreader rows which are the source of the inoculum for the rest of your test entries. So banded leaf sheath blight, in which we are doing the mass culturing of Rhizoctone solani on the barley seeds. The cultured barley seeds we are putting in between the sheath, and then giving it a misting facility for 1 or 2 days, and then we can observe the symptoms. Within 2 or 3 days only, in this case, we are observing the symptoms. Similarly, for the Turcicum leaf blight, we are growing the culture on the sorghum grains. We are grinding the sorghum grains, put that grounded sorghum in the whorls of the plants, and then take the observations after 30 to 40 days of inoculation. Next. So now coming to the post-flowering stalk rots, which we are doing, is it because it is a soil-borne pathogens, we need to have something in the soil. In that case, what we have done is we have developed the sick plot, the same one, yeah. We have done the sick plot where we are, Natalia, the same one, yeah. So in this case, we have developed a sick plot of the 0.5 hectares, and we are continuously growing our test entries. In that, we are and the highly susceptible entries, we inoculate them, we are plowing back the stubbles in the field, and then planting in another season our test entries. So, but in that case, we are having some chances that there will be some escapes. In that, to have the surety that all the entries are inoculated uniformly, we do the toothpick inoculations. And we inoculate it on the second internodes, and then we give a little bit of drought during the flowering, and then we take the disease scoring at the time of the harvesting. Whatever the picture it is there is like the Fusarium stalk rot in our the fields here in India. Next. So what now, coming to the biotic stress management. Our mainly purpose is the biotic stress management through host plant resistance. So what are the strategies that we are considering is the multi-location phenotyping in collaboration with the partners. Then we are doing the population improvement through recurrent selections under disease pressure. And then we are doing the trait mapping for the discovery, validation, and the deployment of the trait markers wherever it is possible, and incorporate the resistant lines in our product profile based breeding. Next, Natalia. So, because of this continuously artificial inoculations and doing it at the hot spots, what we have seen upward trend observed in our heritability estimates. If we can see, we have started in somewhere in 2005, the heritability estimates were approximately 0.223 to 2.5, and now whatever by the year of 2022, we have gone up to 68% approximately. This shows that how with a proper handling and precision phenotyping and inoculation at the proper status, how we can improve the quality of our data. And it is not only case with this one. Can you go back to back slide, Natalia? The previous one, yeah. So it is not no, the same one, yeah, thanks. So it is not the same case with only for the fusarium. We have started with the fusarium ear rods as well, or for the Tursicum leaf blight, where we had initially a very low heritability, but with the precision and the management, we improved it. And because of that, next slide. Next slide. Because of that, we have put our studies in the molecular genetics studies, and we have published many papers, and we have discovered the markers, we are validated the markers, and we are using, based on our phenotypic data, we are using those markers in our breeding pipeline. These are some of the molecular genetic studies which were done in CIMMYT Hyderabad, and now with the, considering the results, we are using some of the markers in our breeding pipeline, which are in the deployment stages, and then there are some of the markers which are still in a validation mode. So what is the conclusion is, if we have to counter the current and emerging threats to the plant health, it requires the holistic approach. It to meet the current and the future climate needs, new tools needs to be integrated in to increase the breeding efficiency in the different product profiles. Networking should be improved in all the research groups to benefit from the divergent germplasm technologies and expert, and to deliver the best products to farmers. And the implementation of the context-sensitive, eco-friendly, gender-responsive, and socially inclusion integrated disease and pest management approaches to reduce the impact of devastating transboundary and newly emerged pests and diseases. Yeah, that is all from my side. Thank you so much.
Thank you, Zerka, for the great presentation. Natalia, I think you, okay. I couldn't, it's fine. You could share the screen. So I think we will skip the second full opinion. I already put it in the chat. So please just one very brief sentence. Tell us what you think. How do you believe that the challenge discussed in this webinar can be addressed to build a more resilient and nourished future? So no need something big, just share with us. And if you don't have the time to think now, just share with us in the LinkedIn, probably where the VIB will share this seminar also. So the main ideas in this webinar discussion is that grain quality phenotyping bridges agriculture and its products with food, diet, and nutrition. Also enable the breeding products and enhance the understanding of genetic diversity. It supports the development of rapid phenomics tools to accelerate breeding processes. Disease phenotyping to identify the resistant sources, that is crucial for improving the yields in stressful environments. But also using both molecular and conventional breeding methods, it's important to incorporate the resistant sources in various genetic backgrounds. So now we can address the questions from audience, and if we have time, we can make some questions to Natalia and Zerka that we were thinking, but we are already a little bit over the time. So I request for people to raise their hand and unmute themselves. Meantime, we have a question from if I don't mistake, let me check, please. I will stop to share. It's from Adanesh. So Adanesh, can you unmute yourself and ask your question, please?
Yeah, thank you. Good afternoon, all of you. I am Adanic. I am from Ethiopia. So firstly, I would like to thank Natalia for her good presentation. And I do have one minor question for her. I just want to know whether the grain size have the direct relationship with the nutritional composition content. Yeah.
Thanks, Adanesh, for your question. Yeah, if I understood well, just kernel size is the question, no? Kernel size and the nutritional characteristics. But actually, there is no correlation between kernel size and nutritional characteristics. However, there might be some correlation between certain properties like kernel color, for instance, with carotenoid accumulation. So the deeper the yellow, the higher the concentration of total carotenoids. However, we cannot infer that given the strong yellow color, we will have high concentration of provitamin A carotenoids. So it is very limited the grade of inference that you can do based on the chemical or based on the physical properties that you can say the nutritional composition of the grain. You always have to go to a more detailed analysis to determine the composition.
Yeah. Thank you.
So if you have any question to Natalia and to Zerka or even to myself, just please raise your hand and unmute yourself. Meantime, I have a question to Zerka. So Zerka, what are some of the strategies for addressing the spread of new pathogens, taking into account all the new technologies in phenotyping?
In phenotyping, so firstly, what we have to do is if we want to see that how to control it, it should start from the seed. So we have to make sure that the seed whichever we are shipping should be free of any pathogens. Wherever we are sending it, there should be a proper quarantine facilities which will monitor whether it is having any disease or not. So then what we can just see is the surveillance is a very important aspect of identifying and knowing whether the pathogen is some new pathogen has come or not, whether some new disease has come or not. So that surveillance is one of the main factor that I can just tell that is what we call very important for knowing the whether the new pathogen or the new disease has come in.
Thank you. So there is a question from the VIB. Please, can you unmute and ask directly to Zerka, please?
Yes, hello. Yeah, as a nematologist by training myself, Zerka, I really would like to know if you're also looking at nematodes, because we know they're a massive problem also as soil-borne and soil pathogens. Are you assessing that anyhow?
No, we say in that case, we are now directly working on the nematodes. So, but we are seeing whether there is a problem which will, like whenever it is a soil-borne pathogens or whether it's a bacteria, fungi, or nematodes, we don't know what is it actually because it's beneath the soil. It's a compound effect. and then one fine day we will see that the plants are lodging. So, but in a particular, I'm not working on the nematodes, but yeah, definitely we are seeing like if there is some kind of the pests or the nematodes present in the soil, which can aggravate the post-flowering stalk rot disease, because it's a compound effect.
Yeah, actually, what we have also seen is that sometimes the nematodes become the entry points for other bacteria because they create these lesions in the root systems. They open these highways in the root system of the plants for anything else to come in. But I was just curious. All right. Thank you so much, Zerka.
So anybody else want to ask any question? Meantime, I think I can ask one question to Natalia. Natalia, so what traits should we prioritize when breeding gains for whole grain usage? You are muted, please. I can repeat if need.
No, that's okay. Thanks, Anna, for the question. And yeah, actually, these days we are hearing the importance of whole grain as part of our diet because of the nutritional benefits that they have. So when we are thinking about having varieties that are suitable to be used straight for a whole grain, we have to think about the storability of the flour, because as we know, when we store the flour, it can get rancid very quickly. So we have to monitor the rancidity, the rate of rancidity of the flour in order to promote those varieties that have lower rates. And also, and there are indirect measurements or indirect ways in order to develop those varieties, including, for instance, varieties that have higher concentration of antioxidants that will prevent the rancidity. That's one of the characteristics that we have to look. And of course, the fiber content, because one of the things that we want to get out of the use of whole grain is more fiber consumption. So the more fiber, the better. Yeah.
Thank you, Natalia. Thank you very much. I don't know if any participant have any other question to make. If not, I don't have more questions from my side, and I can say that thank you very much to the IPBO for the opportunity. Thank you very much to Sarah, to Laura, Modesta, Nietzsche, Veru, and Kim. I hope I'm not forgetting anybody, so I pass the word to Natalia, to Zerka, and also to Laura if they want to add something else. Thank you very much.
No, thank you. Thank you for the opportunity. And we look forward in case you have any further questions. And yeah, thank you very much. Have a good evening or day or afternoon, wherever you are.
Yeah, thank you so much from my side. And if there is, as Natalia said, if there are some questions or queries, you can just email us. And yeah, thank you so much.
Yeah, and I want to say big thank you to these three researchers who have done a fantastic job. Sometimes we don't realize how much work it takes to do a seminar, a webinar, the coordination and back and forth. And I want to especially thank my colleague Sara Fiorito, who is behind the scenes. She's done a massive effort on organizing, and I hope she can switch on her camera if she's here, because like making sure that, you know, everything was in place, links were ready, people were coordinated beyond, of course, the fact that the three scientists have done themselves. So this would not be happening today without our three phenomenal scientists and another phenomenal staff, which is Sara, who is very hardworking, and very happy to have her in our team. So I don't know whether Sara wants to say something herself as well, but
yeah, not really, but yeah, thank you everyone, and also Anna, Natalia, and Zerka for yeah, the great work that you put in this webinar.
And we are going to put this video on the IPBO YouTube channel. But of course, as we had said before, Ana, Zerka, and Natalia are CIMMYT scientists. So when you go to the CIMMYT website, you should be able to find their emails. We have also shared these emails in the chat, but you will also have their full names in the description of the video, so you can also go and find them back eventually. Oh, sorry, we have Mulatu with one question. Can we get that one, please?
Yes, yes.
Okay.
Thank you very much. I'm from Ethiopia, and my question is: I have seen some diseases from your presentation, especially on MLN and the TLP. There are a lot of major diseases in Ethiopia, especially TLP and the fall arm disease. Did you have the plan to work with us in the future? I haven't seen some works from Ethiopia or Sub-Saharan Africa. I have seen only from Latin America and Asia. So how about your plan in the future to work with us in Sub-Saharan African countries?
I think CIMMYT is already working in Sub-Saharan African countries. We are having the offices in Kenya, Nairobi, and I'm sure that we are having an office in Zimbabwe as well.
So
Okay.
Zerka, maybe I can add, yes. So I showed in one of the slides of the presentation that we have the facilities even to screen here the MLN in Naivasha.
In Naivasha, yeah, because Dr.
in
Suresh,
Nairobi.
Dr. Suresh is the concerned person who is having a very good facility for screening of the MLN, and in Africa we are closely working with the NARS partners. So yeah.
Thank you.
Laura, you are muted.
Thank you, Anna. So I also invite Mulatu to contact Anna, who is in the focal point in East Africa, of course, and in Africa, I think the whole. So you can also discuss with her wherever, if there is any particular element you want to bring up for future collaborations, of course.
Yeah, and
Thank
if
you
it's
very
not
much.
related to genotyping, it can be addressed to the scientists here, the Maize team, definitely.
Thank you.
So if there is no more questions, I think we can put an end to this webinar. Thank you very much for the opportunity again.
It's been an absolute pleasure, Anna.